My name is Pablo Pazos. I'm an engineer from Uruguay. Next, please. And today I will talk about um, how we build openEHR, EHR systems, and my experience on that. So I've been working with openEHR, openEHR since 2006, so some years, and also worked with HS7 and other standards. A lot of technologies down the road. So I'm a computer engineer, and mainly my role is software architect. I work in interoperability, so I create interfaces between systems. I help companies to integrate their EHRs with the current systems applications that are working in hospitals when they buy a new EHR, etc. I also teach and train and coach, and I research a little if I have some time free. So I'm living in Uruguay. It's a small country between Argentina and Brazil in South America. And I'm working from here. I'm working globally. I'm working from the US, for Europe, and here for Latin America. And that's it. I just help people, companies to implement EHRs, e-health systems, and implement standards on them. So if you want to contact me, there you have my email and the company URL. Next, please. So what I want to talk today is, well, how we go from the specification to having a working system that implements openEHR. So I will be talking about the most common problems we need to solve as developers to create this kind of systems. So first, we need to solve how we store the information. Then we need to see how we design the whole system. Then we need to design the user interface and how we recording data in the system and storing it. How will we validate that information, and then how will we query that information, that data, and we visualize that data on the user interface. And then I will go do some and explain the big picture, what is behind this, and if I have time, I will give you a quick overview of the current state of openEHR in Latin America. Next, please. So, how we store openEHR data in our database. Next, please. It's the first problem we need to solve when we start developing systems. So, openEHR doesn't define a way of storing data physically. openEHR defines how to model the data logically. Next, please. So this is good because we have freedom on the technology part. We can implement this in any technology we want. But the bad thing is we have a learning curve because we need to go from the specification to a database design. And this sometimes seems to be more work, but I don't know if it's more work than creating a non-standard based database design. So next. One thing we need to understand when we are designing how we will store information, clinical information, is we need to understand the nature of the clinical information itself in paper. So in paper, we have highly hierarchical structures. So we go with, we have the EHR, we have different folders when we organize documents that are on paper, and those documents are divided in sections, and we have fields where clinicians record data by hand. the structure of the clinical information can be very complex because each clinical document has its own structure, and we have highly variable structures. Maybe the blood pressure for a general practitioner is recorded with format A in one clinical document, but when you are I don't know, a cardiologist, you record the blood pressure differently in your record, in your format of the paper record. So we will have highly variable structures, and we will have a lot of structures, and also we will have a lot of types of data. That on paper that doesn't really matter, but on electronic records we need to know which type of data we are recording. Yeah, because with this will be linked to the database and to a programming language. And on a database and a programming language, we need to know the type of the data. So the good thing is the openEHR information model represents this structure, this hierarchy really good. So the information model is very generic. You can have any kind of structure represented with the information model, and with any complexity. You can have one big field with free text, or you can have all the data structured. And also this model is small and stable, and we need to implement this model in our software in order to implement openEHR. So it's good to have small things to implement in our software, because we'll have small software and stable software. That's good. Next, please. Then we need to understand what we need to do with the data. So we are trying to choose a type of database and try to model the database structure. So we need to know which kind of use we will give to the data and how we will store the data and query the data. So there are different database types, let's say, depending on our requirements. So we have the operational clinical data record. That's the most common database, because it's the database we have under the systems that for data entry. They support clinical sessions and transactions with users. Then you have the shared clinical data repository, that is more like a backend database that stores a bunch of records from different data entry systems. So there you have full EHRs. There you have to support the versioning of documents. Yeah, and really the difference is the system you are using the database. So it's data entry or it's a backend database to aggregate a lot of data. Then you have the documental database is to have full documents. So in shared and operational CDR, you have like atomic data. You have individual types of data. And in documental you have full documents. It's not that you have individual atomic data. So there you can record or organize the record in folders, and you can have episodes organized in folders, and you can implement from using that things like IHE, the cross document sharing profile. There you have temporal series, real time. Let's say you have some device that measures in a time-based manner some kind of medical data, medical information, and that should be recorded. Is a small bunch of data, but it records that really quickly. So we need to store that. Is a different requirement. Then we have analysis databases. This is mainly for research and knowledge discovery, and you can implement different kinds of algorithms to find data and link data together. So this is more for research. And the data warehouse is for data visualization of the history. You can disaggregate information in different ways. So you can it's mainly for management. You can know how your hospital is doing by implementing a clinical data warehouse. This is a requirement, but you will have to choose one type of database to deal with these requirements. So the problem is really when you have more than one requirement and you want to use one database type. So the most common database type is the relational database. We use tables for that. Then you have documental, object-oriented, multidimensional, graph, etc. I will not bother you with all the details of those. You can search in the internet. But you have different types of databases for different types of requirements. Next, please. So the lessons I learned, and this may help you implement your own systems. So there is no one fits all solution. So if you have different requirements, don't use the same database type. Try to use different database types specifically to solve your problem. You will end up maybe with duplicated data, but that's not really a problem. You will find that if you force one technology, one database type to implement something that is not designed to solve, another type of use of the data, you will end up with a lot of headaches, and it's really simplest to use the specific database type to the specific problem. And if you let's say if you choose to go with one database type, when you are developing and when you are trying your system and when real users are using your system, you will find the problems, and there you will have an opportunity to improve. So try not to improve, previously that when you don't have the problems, when the problems are all in the theoretical field. So try to choose one, go ahead, implement your system, then find the problems, and then go back to the design board and start again. That's how it is. So you have to do it. You can improve performance, you can tweak it, and if you need, you can change the database type. So keep that in mind. Starting with relational databases is easy because we all know those types of databases, but we have to keep this in mind. If we want to implement the openEHR information model in relational databases, we have two main ways, let's say. We can design our own schema. The schema is the structure of the database, and the mapping between the information model and the database model. The information model of openEHR is object-oriented, so you have objects there, and the relational model is the relational database. It follows the relational model. So you have two different models that you need to map or link together. The other way of implementing this is to use an object relational mapping tool, the ORM tool. So you can automate that mapping because those tools implement that exactly that, the mapping between the object-oriented world, let's say the openEHR information model world, and the entity relational model, that's the relational database world. And you can tweak the automatic generation of the schema if you need it. Next, please. So if you use modern technologies and modern programming languages, almost all are object-oriented and support some kind of object relational mapping. So you won't have any problems there. Two main things that these tools provide is the auto-generation of the structure of the database, based on the model you have. So if you implement the openEHR information model in your programming language, then you use an object relational mapping tool to generate the schema, and you will have the schema, the structure of the database generated for you. So this means that you will have less things to specify and to maintain in time. That's good. Less errors because the process is automatic and it will be consistent every time that you should generate the database. Because the information model doesn't change too much, you don't need to generate the database structure all the time. So that's nice for stability of your system. And you will have, sorry, you will have your system out there quickly because you don't need to do these things by hand. So that's good. The information model is small. The openEHR information model is small, stable, and flexible. So if we use auto generation, the structure of the database will not change in time and can store any type of or any kind of structure you want to store. So you have a lot of flexibility there. So if you need to change the system in the future, add different structures, you don't need to change the database structure. That's great because the information model is already very flexible on that, very generic. And the specification of these new types of information or the change of current structures of information will be defined in archetypes and operational templates, OPTs. So you will have standardized way to define your data in your system, and the definition of the data will be outside the system. So that's a nice feature. Your system can evolve, you can add more document types, more record types to your system without changing the system itself. So that's very, very nice. And object relational mapping tools provide some APIs, some interfaces to query and to store data. So using these interfaces also is simpler than using SQL to query the database. It's more maintainable. It's more testable. You can test easily how you use these APIs than testing queries is really difficult. And the result of the queries will be objects. There are not records on the database. Are objects that you will use in your programming language like any other object. If you're a Java developer, you can try Grails. It's a great tool, and it has an ORM tool itself that is very simple to use. Next, please. So the next thing is you have to think about the whole system structure, the whole system architecture, the components, and how those components will communicate with each other. So next, please. The first time you create a system, you design your system, and this is my story. Maybe 6 years ago, I wanted to create a system based on openEHR. And the first architecture I think of is just implement all the layers in one system. So you have user interface, you have logic to process information, and you have the database to store the information. So you have data entry in the same application that you maintain the EHR information for each patient. So this is centralized. And it is very monolithic. That's the mono up there. And this should handle the operative CDR, the clinical data record, and the shared EHR functionalities that the two first database use I mentioned before, because you will handle how users interact with your system, but you will also handle all the data from your patients in the same system. So you have scalability problems here because if you add more patients to the system, more specialties, more medical specialties, or you want to provide access through more devices to your data, it's difficult to implement that this way because every time you need to add something, you need to change the whole system, and you need to touch the three layers there: the user interface, the logic, and the persistence. So if you think of, well, I want to add more flexibility so more users can access using different types of devices, you can think of the next, let's say, the evolution of this. Next, please. And you can separate this into a front and back end. So you have two different applications, and the user interface is just a thin client. It doesn't have logic, it doesn't have persistence, it's just the user interface, how they you show the record to the user, to the medical user. So that's for data entry and data visualization, clinical data entry and clinical data visualization. Well, you have all the user interface in one application, and you have the backend in another application. So it's more flexible in that way, but you need a little communication protocol, let's say, or an API to communicate that data between those different applications. The client is very light, I already said that. This is still more flexible for the user interface, but it's still difficult to integrate with other systems. So if you see down there, you can implement like a web interface, a mobile interface, a desktop application that communicates with your backend. So you have flexibility on that part. But then you will find the next step. Next, please. That is more. This is like today's view of how we need to design our system. Is more service-oriented. Let's say we use service-oriented architecture, and we are friendly with cloud and mobile. So your data entry applications will be full applications. Those will have the three layers, so user interface, logic, and their own database. But they also need a communication layer to communicate data with the backend. So, and this application will manage only the operative or transactional data and the clinical sessions with users. They won't handle the EHRs, the full EHRs of our patients. So the backend will handle the full EHRs, and they will share the EHRs, and they will provide services. So different client applications, different applications that will design and build will communicate with this backend. So if you have one application, let's say for cardiology, and you have one application for emergency care, and you have another application for ophthalmology, and all those three applications use different technologies because there are full applications, so they have their own user interface, logic, and database. They can be different, but those all three will use the same interface to communicate with your backend. So let's say that all those three send information to the backend. Then when you query the data from the backend from those applications, you will get the full data record for that patient. Let's say you will, from the ophthalmology application, you will get also information from the cardiology application and for the emergency application. Yeah, that's helpful because you will, let's say, record the blood pressure of the patient in every application, and you need all the blood pressures of the patient. It's not just the blood pressure of the patient that I record from my application. You need a full view of the patient. That's the shared EHR role there. So this is not centralized approach because the backend you can create multiple instances of the backend, and you can synchronize between them. And out of the box, you will get nice features if you use this approach, like backup, fault tolerance. If you have redundancy, you will be fault tolerance. If one of your servers fails, you will have 3 more working. So no problem there. You have reliability, you have disaster recovery for the same reason. You have high availability. If you have a lot of users, you can distribute the loading of your system between all those instances of the backend, and you will have also less response time if you have servers located in different locations. So the backend will have a robust API to integrate client applications, and mainly here you will have 2 services. You will have the commit service that is to feed data to the shared EHR. So you can send data from client applications from data entry applications to the EHR of one patient, and you can query that data from the EHR, and you can visualize the data on the client applications. So this is a more scalable approach, and you can grow with this. It's really nice. Next, please. So just a concept diagram. There you have on the left the client applications, let's say the data entry applications and data visualization applications. You have all the layers there, but you have also the backend, and you need to communicate those through this interface, through this API. So openEHR is prepared to do this. openEHR defines the information model. openEHR defines, so that's how we store the data, defines the specific data structures, let's say clinical documents that are defined on archetypes and operational templates, and define a service model. So you can, send information and share information between systems. So you can send and query that data. Next, please. So in the left, you have a diagram with many applications and the shared EHR, one instance of the shared EHR, and on the right you have more than one instance of the backend that will synchronize themselves. So it's just a copy of the system that, and on each one you will have the same data. So when an application sends data to the backend, there is no need to know to which server that application is talking. That application can talk with any of the available servers on the backend. That's the cloud approach. Yeah. Next, please. But for this to work, you need all the metadata. Yeah? You need some repository, some service to provide you of archetypes, operational templates, terminologies. Also, you need UI templates. I will talk about this later. You will have rules also for clinical decision support. You have alerts, recommendations, reminders, etc. You have guidelines, workflows, etc. All the definitions that your system needs need to be stored somewhere also. So keep that in mind. Next, please. So the next thing you need to worry about is the UI. How you will generate the UI, how you create the UI, and how your users will record data in your system. So next, please. In the current way of creating systems, we all design and develop UIs, user interfaces, by hand. So we need a lot of time, and it's difficult to maintain user interfaces, and it's difficult to evolve. And when a small change is requested, we need to change the user interface. So we need to change the code of our application. So that's something that takes a lot of time. So it's tempting to think of creating something, some component, some tool to auto-generate the UI. Yeah, but it's difficult to create one that is generic enough to work with any technology. So, and and I will tell you why. The good things of having automatic generation of the user interface is you will have consistent UIs through all your system, because you will use the same generator. Obviously, you need less time. To have working user interfaces compared to creating them by hand. You will have less errors, and you need less tests to do on the user interface. So this is good for rapid prototyping and requiring validation. So if you have a bunch of user interfaces, you can and those doesn't need to be working. It's just the user interface. So you can show the user interface to your clinicians, to your end users, and they will tell you if you are in the right direction or not. So instead of developing a full system, you just generate the user interface, show them to your users, and your users will tell you what's wrong, and you can come back again, improve, and generate the user interface again. So that's really nice. The bad thing is the user interface that is generated is not so flexible, and if you need a really customized user interface, because you want to design pixel by pixel all the user experience, it's really difficult to do this with something that is generic. So it's really custom, and that should be done by hand. But you can generate the UI and tweak it after the generation. Also, the generator will need some kind of metadata to generate the user interface. But once you specify the metadata, the generation will be automatic. So it's not a real problem. And then when you have the user interface generated, you will need some work to wire that user interface, those artifacts, into your system, into your specific technology. Next, please. So what's the metadata you need for UI automatic generation? The thing is, archetypes define data structures, but they don't include information about how they will be displayed to users, how the user will see the structure, or how the user will see the structure of the record to start entering data. So we need more data over the archetypes. The thing is to have some kind of metadata that will use archetypes, because all the data is defined by archetypes. So there is some link between this UI metadata and the archetypes that define our record, our clinical record. So after some time of researching and developing, we design a methodology and a specification of this metadata and a tool that generates this. So we have a model, we have XML format, and we have a prototype of a universal UI generator that generates for different technologies. That's great. So it can be done. That's the key message here. Next, please. And there you will see an overview of the model, the metadata model for UI. We call this UI templates. And I will not get into the details of this. This will be published this year in a paper. We need to tweak the model a little, but the basic model is that. And you can see that from the model we define different views that are like screens, and from those screens we reference different archetypes and different fields that are data fields defined on the archetype. And there we have a lot of metadata that we use for the generator. So we tell the generator where to put the data, how to organize the data in the screen. So that this model is for that. Next, please. So what's the idea behind this? So we have the methodology is a multi-level modeling methodology. we use the dual model as a basis, the openEHR dual model as basis. The openEHR dual model is the information model plus archetypes and operational templates or templates. So the diagram down there, I want to take some time to explain this because I think it's really important and useful. You have the information model, you have some observation and mapping tool, and you can generate the structure of your database. That's the first box there. Then you have the archetypes and operational templates that define the specific data structures and define also rules. So you can use those rules to validate the data that you will record on your database. And then you have this new component, the UI templates, that with a generator, you can generate the different user interfaces. The nice thing about this is we will have tools to edit templates and archetypes. So these tools will be used by clinicians, so that's really nice. And we need to create the tools to generate things and to use this metadata in our system. So that's the part that informaticians ourselves, developers, come in, and all the system will be, let's say, generated by this metadata. We just need to create more intelligent systems, but this system will change its behavior, the way it looks also because of the user interface, if the clinicians change the metadata. So if they add a new archetype and they generate a new user interface, they will have a new record on the system, and without changing the source code on the system. So, and after we have UI templates, we can define also workflows, so how we navigate the user interface, and we can have other types of metadata. Next, please. And here is just an example of one screen that is generated. This is, sorry, the labels are in Spanish, but the idea of this is this is the triage of trauma for an emergency department. From an archetype, and the system has a triage archetype, and it takes it and generates some HTML. This is a web-based system. So next, please. You can generate any complexity of screens, just configure the archetypes there and define some metadata, and you will get screens. Those are not so beautiful, but are auto-generated. So you have a lot of free time to improve how these screens look like. So next, please. Now we have storage, we have user interface, we have like the design of our architecture. So we need to start recording data on the system and validating that data. Next, please. So this process will explain to you how we use archetypes to validate the data, because archetypes are really constraints. So it's simpler to use those constraints to validate the data instead of you writing your own constraints to validate specific data. So if you write your rules to validate specific data, and you will need to change your system, you need to change that also on your system. You need to open the system and change the source code. With this approach, archetypes are defined outside your system. So if you change a rule, you change an archetype outside your system, and then you feed the system with that new archetype. So the behavior of the system will change from those configurations, from those changes on the outside, without changing the source code of the system. So to explain for you the workflow, I will start on the top left. So you have a user interface when the user records some data, and the data is recorded for one template. We say that the operational templates define clinical documents. So all the data you record there is related to one clinical document. So it's related to one template, operational template. So there you have operational template ID and data is a set of data. So you have some structure there. Then on the logic of your application, you will find the template. Yeah, this is the operational template of openEHR template by the ID, and then you will validate with the template and the data. You will try to find the constraint on the template, and you will evaluate that constraint with the data, with a specific data point. Yeah. So each data, that's the key thing, has a path. A path is an identifier of a constraint inside the template, inside an archetype of that point of data. So if you have a blood pressure archetype, you will have a path that it identifies the systolic blood pressure. And if the user enters data for systolic blood pressure, you can go with the path of that data to the template or the archetype to get the constraint, and you can apply the constraint, evaluate the constraint against the data, and that will tell you if that data point is valid or not. If all data points are valid, you can go to the database. You can structure your data, and you can save the data on the database, and you can use here the object relational mapper to do that. So that's it. It's simple as that. It's just going to the template or the archetype to get the constraint, evaluate the constraint against the data for all your data, and if you find an error, you just go back to the user and tell the user what's wrong. If you don't find an error, you just save the data on your database using the tools I already mentioned before. So it's really easy to do things like that. Next, please. So now you have database, you have user interface, you have data validated. Now you have data on your database. How you will pull the data from our database and visualize the data. So query and visualization. Next, please. Think of the architecture I mentioned before. We have client application, data entry applications that will send information to the backend. Yeah, the backend will receive that information and will process it, and will be the information will be made available for querying. Yeah, let's say we have vital signs data. Yeah, blood pressure and heart rate. Yeah, I will show you an example in 1 second. So all the data is defined by archetypes and operational templates. The data queries, so how you define which kind of data do you want to be retrieved from the backend, yeah, are archetype based. They don't depend of your technical infrastructure. They are defined using archetypes, archetype IDs, and archetype paths, as I mentioned a minute ago. So on this approach, almost all implementations have some query builder that is UI based. So you have a tool to generate the queries, and it's a clinical query builder. It's for clinicians. It's not for developers. So clinicians know the clinical information. We don't know the clinical information. They know the concepts, the terminology. We don't know. So there is no need to change the system every time we need to add a new query. We just create the queries using a user interface. And we will create queries that are not technology dependent. If you use a SQL database, you will note that SQL is a standard, but each database vendor extended the SQL language, and those extensions are not compatible with each other between vendors. So it's difficult to have, like, generic queries you can use in all your systems if you use the SQL approach or the normal approach. And also, if you use SQL to query data, you will end up with, if you need a new query, you need to change the source code of your application. That's a problem. And openEHR defines a query language. Personally, in the systems I created, I don't use AQL to define the queries, but we will implement AQL to export the queries instead, to share the queries between systems. So next, please. So the query builder, it looks like this. Is the user interface is not so nice, but you will get the idea. So first, you need to, let's say you are a clinical user, not an informatician. So you create your query. You need to define a name and which type of query do you want. I want to get data from the database, so I put there data value. Then I need to tell the system that I want vital signs. So I select the archetype for vital signs. That's the Spanish. Their signos is vital signs. And you select which kind of data do you want. I want blood pressure and heart rate. You have a full demo of this in YouTube if you want to look it after the conference. Next, please. The other part of the builder is when you specify how you will get the information, in which format, and how the information will be grouped together. So if we group by path, it allows to retrieve temporal series with of the same kind of data together. So, and we can test the queries in the system while we are creating those. Next, please. When you execute your query, you will get data. So in this time, the data is JSON data, so it's very web friendly, but you can also get XML, and almost all the implementations I know, the openEHR implementations support some kind of JSON or XML data retrieval. And there you can see that you have blood pressure, systolic, diastolic, and heart rate, and you have 3 data points for each path, let's say, and each data point has its own unit of measure and a point in time. So it's really easy to chart. Next, please. So that data, if this EHR server finds that the data can be charted, it will chart the data automatically. You can create also views, tabular views for the data if you group the data by composition. It's by clinical document. It's easiest to group the data differently if you want. So this data will be retrieved to an application from the server, from the backend. Yeah, so the application can, process the information and show the information to the user any way you want. So that's really nice. Next, please. So I will give you, next please, the big picture. So we'll go back, do a little zoom out. What are we creating here? So we really are creating an infrastructure. We have an infrastructure, and we in the normal approach is to create our applications above our infrastructure, the servers, the networks, the databases. So now we will add a new layer of systems that creates an information infrastructure that lets us to manage better, define and manage the information better than on the current system. That will allow us to generate more intelligent systems, more capable systems, and also interoperable systems out of the box. Yeah, this is like defining an app store when you have a lot of services behind data services, and you create your own applications, and you can sell your applications, and you can get information from the services that your infrastructure provides. And you don't have to worry about the infrastructure. So it will be there. It's just in the cloud, let's say. So the important thing here is the metadata. All the system will be based on metadata. And then if we create this kind of system, we will have an innovation space on the application part of this structure. Yeah, because there you will create services for companies that they don't have the knowledge of creating these systems by themselves. So they don't have the clinical experience, they don't have the technical experience or the standard knowledge. So we will put that in the infrastructure. We will define the methodology of how we handle the metadata, and all the system will change with the metadata. Yeah. Next, please. And quickly, I have 2 minutes. I will try to explain, let's say, my journey of these 8 years of openEHR in Latin America. Next, please. So there you have some big points in history about what we were doing here in Uruguay about openEHR. I won't get into the details. You will have this presentation later. Next, please. One thing that is important is we designed 4 years ago a course, an online course. This is the first full openEHR course online, and we had 4 editions of this course with students from 15 countries here in Latin America, and also from Spain and Portugal. That's really nice. And right now we are in the middle of the 4th edition of the course. So the course really on the first 2 editions nobody knew about openEHR, and on the last 2 editions they are asking more and more how to implement openEHR. It's just they already know what it is, and now they want to try it and test it and see how it works, and improve their systems using openEHR. Next, please. So I have an update. It's a very simple update about the current state of openEHR in different countries. I don't have much information about this. It would be nice to have more. Next, please. And the thing is that openEHR is gaining interest in countries here in Latin America. We just did the awareness and interest stages. So we passed through the awareness, and now the current stage is individuals and companies and are considering to implementing the standard on their system, or at least to try the standard. And next step is to really go through and start working with the standard. And some companies are already here. The thing is that a couple of years ago nobody knew about openEHR, and now everybody is talking about it and everybody knows it, and a lot of people, a lot of companies want to implement this in the future. Next, please. Some conclusions. Quick. Next, please. openEHR is gaining momentum here and also in Europe, in the world, let's say. We have a growing community. The industry and the government are more involved day by day. So there are national-wide projects that includes in their request of proposals that for buying technology, they include openEHR related requirements. That's really nice. This year it was the first request for proposals in Uruguay that requested to have archetypes. That's crazy for us, but it's really good. The thing is that there is no other standard or technology agnostic approach that is a good alternative right now for to have future-proof interoperable systems on the market than openEHR. It's the only standard that is focusing on these things. So and the problem was some years ago, all HL7 guys looked at openEHR and considered it harmful, because they considered that it will compete with HL7. But now HL7 has understood that openEHR is not an alternative. It's totally complementary to HL7, so we can use both standards in the same system because their focus is very different. They solve different problems. So openEHR, open source software is improving day by day. That's really nice. And openEHR is a good and elegant solution. And no one proved otherwise since 2002 when the standard was created. So next, please. So go for it, integrate it into your system, into your technology stack, and make healthcare compute. Next, please. Thank you.